Hello everyone. In this video, we will be talking about conservation of momentum. As we discussed earlier in a different video, momentum is a physical property of moving objects. When we were considering energy, we saw that energy was conserved during an event. For example, when a ball was dropped from a certain height, when it was raised to that height, it was given potential energy. And when it was released and the energy returned to the bottom, all the potential energy goes into kinetic energy. But in the end, the energy sum in the system remains the same. Similarly, in momentum, whenever you have collisions, the momentum of the objects in the collision remains the same. So, the essential rule is the momentum before must equal the momentum after. Let's see this rule in application using an example problem. Let's look at this example. We have a bullet that is fired at 200 meters per second, and the mass of the bullet is 18 grams. The bullet hits a 5 kilogram stationary box and goes through the box. When the bullet comes out on the other side, it has a velocity of 120 meters per second, and the block will also have a velocity. We want to know the velocity of the block after the collision. So let's look at some of our known values. We know the mass of the bullet is 18 grams. Mass of the box will be 5 kilograms. Velocity of the bullet before, which we will refer to as VB1, is 200 meters per second. And the final velocity for the bullet is 120 meters per second. That is after it comes out on the other side of the box. We'll use conservation of momentum to figure out the velocity of the moving box. By conservation of momentum, we know that the momentum before the collision must equal the momentum after the collision. So, before the bullet hits the block, what are the momentums of the two objects? We know the momentum of the bullet will be the mass of the bullet, which is 18 grams, times the velocity of the bullet, which is 200 meters per second, plus the momentum of our box. But the box is stationary, so the momentum of the box will be 0. After the collision, we know that both objects are moving. We know that the momentum of the bullet after the collision will be the mass of the bullet times the 120 meters per second, its new velocity. And finally, we'll have a momentum for the box, which is the mass of the box times the velocity of the box, which we'll refer to as velocity of B. Now we can see all we have to do is solve for the velocity of the block. When we do that, we get the velocity of the block after the collision is 0.288 meters per second. Now, conservation of momentum can also be applied in more than one dimension. So it can also be applied in 2 dimensions, where velocities have an x and a y component. But dealing with this is the same way we dealt with projectile motion, or kinematics, when we had 2 dimensions. We just break up the vectors into their x and y. We split up the page, and we deal with the x variables on themselves and the y variables on themselves. So comparing the 2 axes separately, and then in the final scenario, if you need the resultant velocity, that is the combination of the components, all you do is trigonometry again. Be sure to practice those problems. Thank you for watching, and see you for the next video. I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what physics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you're a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the 1st floor of the Sid Richardson building. You will find all the details you need about these services on our website at www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online, or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.